Ladies and gentlemen, what I want to do right now is remind you how to solve a linear inequality. A linear inequality is just like a linear equation. So what will be really helpful is if we can graph a linear inequality just like we graph a linear equation, and it's really helpful if we can remember what slope-intercept method looks like. Okay, this is what we call slope-intercept method. And the reason why I call it slope-intercept method is because M represents our slope and B represents our y-intercept. Okay? So now we know what our slope is and we know what our y-intercept is. Now remember, what exactly are our y-intercepts? Let's not forget about the inequality sign right now. So remember, our intercept is where the graph crosses our y-intercept. So the y-intercept is where my graph crosses the y-axis. So I look up here and I say, oh, it crosses at -6. So I go down on my y-axis to -6. 1, 2, 3, 4, 5, 6. And I make a nice big dot. Everybody in the class should be able to do this because I know the first 4 problems are all in slope-intercept form. So everybody should be able to determine what the intercept is and then to plot it on a graph. All right? Now the next thing we need to do is we need to determine the slope. The slope is your number that's in front of x. Now there's one important thing we need to remember, guys. When your slope, remember slope is a ratio between the change in y over the change in x. Okay? So right now we have a negative, I don't think it was right now, it was right like this. So we have a negative 1/3. Well, does that mean -1/3 or 1/-3? I'll tell you what it doesn't mean. It does not mean -1/-3. This is the most common mistake students want to do. And the reason why I know that's wrong is because what's a negative divided by a negative? Positive. Always gives you a positive, right? So this slope is negative. That means either the top or the bottom's negative. And we'll determine which one it is. So here, to find this out, let's go ahead and use this slope first. So if my slope is a -1/+3, my change in my y is -1. That's going to tell me to go down 1 unit. Then the change in my x is over 3. So I need to go over 3 units. 1, 2, 3. Now I can connect these 2 points and continue them left and right to make a line. But let's check this other slope just to see if we could have used this one instead. So what if my change in y was 1? That means I would need to go up 1. And if my change in y was -3, I'd go left 3. 1, 2, 3. Do you guys notice that? I know my graph's probably not the best, probably right there. But do you guys notice that these 2 lines are all 3 of these points are all on the same line? Yeah. Okay? So really what you can do is just connect all 3 of your points. All right? But before you connect your points with the line, we need to determine what type of line. So you guys should remember from our inequalities on a one-variable inequalities, when we had a greater than or equal to, or less than or equal to, we have what we call a closed dot. Right? Because at that point, our inequality was true. And we had a less than or a greater than, we had what we call an open dot. Right? You guys remember that? Okay. Now, we're not dealing with dots anymore, right? We don't have a number line. We don't just have one number line, right? What we have is we have 2 number lines now. So we're going to be dealing with a line. So instead of doing a closed, we're going to be called a solid line. Instead of an open dot, we're going to be called with a dashed line. So since this is less than, we're going to be dealing with a dashed line. So I'm going to connect these points with a dashed line. Okay? Now, the next thing you guys need to remember is, remember when we graphed a inequality on a number line, to determine which way to shade, remember we picked test points, right? So this is like 4, we'd say 0 and 8. And we'd say, all right, x is greater than 4. And we'd say, well, which way, which one was true? Well, we did test points. And we said 0 is greater than 4, or 8 is greater than 4. And we found out this was true and this was false. So therefore, we shaded towards the true statement, correct? Well, here we have a lot of points. We have an x and a y. So that means we have a coordinate. an x and a y coordinate. So the point that I'm going to pick is going to be 0, 0. All right? Always use 0, 0 unless your graph goes through 0, 0. And the reason why you don't want to use 0, 0 if your graph goes through it, because then you don't know which side to pick, right? If I pick my point 4 and I say 4 is true, well, that only tells me do I shade it in or not. It doesn't tell me which side to shade. So you need to pick a point that's either above or below your line. So how do you test 0, 0? Well, when I had these points, I plugged these points in for x. Well, now I have a point x, y. So I need to plug in 0 in for x and y. So I say 0 is less than negative 1/3 times 0 minus 6. Negative 1/3 times 0 is 0. Is 0 less than negative 6? True or false?
No.
False, right? So make a nice big. So that means all the numbers that are above the line are going to make your inequality false. So we always shade towards the true statement, right? So that's all these points down here. Okay? So if it's false, you shade on the other side. If it was true, you would shade towards the true statement. And that's how you set up your graphing for stuff.
Yeah.